Hello everyone and welcome to this 10th coding challenge video. In this one I'm going to be attempting to make a scene detection script which will detect and then cut or split our video in After Effects based on what it detects as the different cut points. Before we get started with this coding challenge, I do want to remind you down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel, and down in the description you can check out the code once I'm done with this in the GitHub link. Make sure you follow us there for coding updates, and in the description follow us on Instagram for other live updates. If you're not already a member of our Discord server, you can come and join and get help with scripting, extensions, plugins, expressions, submit tutorial ideas, and much more. And if you'd like to help support us financially, you can become a member, supporter, premium supporter, or VIP. Link for that is in the description of this video. So we're just going to get started with this and see how it goes. My goal is to basically just look for large changes in the luminance or color detection of a scene using a script and an expression, and hopefully we can detect pretty accurately the cut points that are required. Now, I don't think I'm going to make a UI for this. I think I'm just going to make the functionality for it. And I also have this here clip, which has multiple cuts in it. And we're going to use this as a good example because not only does it have just normal cuts, it also has this little rapid section. And some of these clips also have flashing lights. So it's really going to put it to the test of whether or not it works. So to get started, I'm going to make a new file. Obviously a JavaScript extended, or in this case if you're using Visual Studio Code, it will say JavaScript React to make a JSX file. Now what we're going to do, since we're not making a UI, we can just define our main function, and we'll call this split scene. Or what we can even do, well, let's go ahead and make like a main. So we'll say function main, and inside of main we're going to check whether or not they have a composition open, and let's assume they're going to select exactly one layer, and that's going to run the detection on that layer. If they had a bunch of layers, they would need to pre-compose it first and then select that as their layer if they wanted to analyze like a composite of things. So the first thing we need to do when we run the script is run main. Inside of main, we're first going to check for comp, and then we're going to check for one selected layer. We're only going to support one for now because this may be a more intensive, heavy CPU kind of process that takes a while. So having a whole bunch of layers at once might be too complex, or just take too much time and freeze everything up. So the way we check for a comp, we're going to ask if app, come on Visual Studio Code, if app.project.activeItem does not equal null, or we're going to check if it does equal null, because if this is true, or app.project.activeItem is not an instance of a comp item. Obviously this says is an instance of, so I can put an exclamation mark in front of it to reverse the logic. So if there's no active item, or if there is an active item and it's not an instance of a comp item, then we know that we don't have an active composition. If that's the case, we'll say please select a comp. Return false so we don't go any further. Then to check for a layer, I'm going to first create a variable called comp. This is going to be app.project.activeItem. If we've gotten this far in the code, we know that there's a composition open and we can now store it. The next thing we're going to ask is if comp.numLayers, if comp.selectedLayers.length does not equal 1, we're going to say alert, please select exactly one layer to analyze. And we'll return false again to not go any further. So if they don't have a composition selected or an active item, we'll tell them to please select a comp and try again. If they do not have exactly one layer selected in this composition, we're going to ask them to please select exactly one, because that's what we need. Now we'll run split scene. We're going to give it our comp, and we don't have to, but we'll just say comp.selectedLayers 0, and that will give us the first layer. And then we need to have these arguments. We'll have our comp and our layer. Pretty simple naming, but that should do the trick. I'm also going to surround this outer thing with an app.begin undo group. We'll call this scene detection. And then after our split scene, we'll say app.end undo group. That way, after we're done reading everything and splitting the footage, we can easily just press undo to undo all the cuts. Now, inside of our split scene, we need to now set things up. How are we going to detect what's going on in the scene? The goal should be to sort of analyze a portion of the screen and get like the luma value or the color value of that, and then compare it to the next frame. If the next frame is like vastly different or something, we need to maybe define if it's maybe 50% or 70% or 95% difference. Then we're going to have a high confidence that that's a scene split area. Now the way I want to do this is with an expression. If I create a text layer, and let's see, I have some code already here that I've used previous to set this rig up. We basically need a point control or something that will allow us to sample the image. Maybe we don't need a point control in this case because we can try and sample the entire image, I imagine. So we want a text layer, and the expression of this text layer is going to be this. Go ahead and actually just go to the source text and paste this. And then we need to replace the things here. In this case, the layer name we need is going to be, actually just reference this comp dot footage layer here. Come on, get that layer. And we have that. We have our sample point. We don't have a null though, or a point control. So because we don't have that sample point, we'll define our own from the center of the comp by saying this comp.width, this comp.height, and then divide each of those by 2. And I know I'm on the wrong side of the screen here. Let me see if I can expand this window. Sometimes After Effects makes it very hard to like increase the size of it. There we go. So hopefully you can start seeing this a little better. In fact, let's put two things side by side here so you can see. The code will be over here, and we can maybe try and write our expression over here. Or not, we'll see. So now we have no errors. What does this text say though? Let's make this pretty big, 250, and something readable, 57. So from doing this analysis at the center point, we're getting the R value of 57. I'm going to change this to R text. And let's create a G text. Move that down a little bit. And I'm going to change in the expression. Instead of getting our sample index 0, we're going to get our sample index 1, which gives us 5. And then we'll have our v text, which is the same thing except the second, or in this case, first index value. And now we have our RGB values being read from the center point of our screen here. Now, it's in 0 to 255 range, so I'll change to 8 bits per channel. And if I find my center pixel, which should be 1280 divided by 2, 640 by 360. So if I find 640 by 360, you can see we're getting pure white. It's because our text is in the way here. Let me move all these. Select here, and this center anchor point is going to lead us to 640 by 360. Gotta be really precise here. And as you can see, it's slightly off in the reading here, but we get 57, 5, and 26 for our values. So we know that indeed this is working to read these pixels. And if we go along in time, you can see it updates accordingly. So now what we want to do is change up the expression. We're going to be using obviously the script to apply this expression, but we just kind of want to understand the workflow for now. So what we want to do now is change it to not sample a very small portion of the screen. And by the way, these expressions I have gone over in previous tutorials, which you can check out. And I just wanted to reuse this code since I've used it so many times. But you can go ahead and, of course, see the code once this is complete in the description down below. So the thing we want to change here, we have our sample point, which is sampling the center of our screen. And we have the sample radius, which is only going out 1 pixel. If I change this to maybe 10 by 10, how much of a different value do I get if I make it 10 by 10 versus 1? You can see it's not a huge difference. Let's go ahead and set the radius to the composition width and height. This comp.width, this comp.height. And now this should be analyzing the weighted or average of all the pixels. So let's see here. If I compare two of these scenes, how different the sums of these two calculations are. So we have this really dark scene, which has a total, we'll say, luminance of 13 when I add RG and B together. So 13 compared to a much bigger number, 352. So that's a, let's check the percentage. That's a 3%, 97% difference. Let's check some less extreme cuts, because not everything is gonna be crazy. And look, even if I go through this here, if I just go through a single scene, some of these values are changing 20 and even more. Maybe I should be comparing the average. Let's see. We had 353. Let's divide that by 3. It's 117. And our other value was like, what? 13. 4.3 divided by 117. It still gives us 3%. Okay. So the sum and the average aren't going to give us anything different. Let's compare these two scenes that cut here. Let's see if we can find something. 64 plus 6 plus 14 gives us 84. Oops. The next frame gives us 120. I wonder if these values change too much, because we're using such a wide sample radius. Let's try divided by 2 on the height and the width for our radius. That probably doesn't change much, does it? 64, 6, 14. Same exact value. What if I change this to like 1? It really doesn't change much. That's interesting. $255. Sample the image with our sample radius. I'm gonna go ahead and look in the expression guide really quick, just so I know all the arguments for this. For sample image. In fact, Let's just load the PDF. Post effect. Masks and effects, which we don't really have that as an issue. So, I think we're still fine in doing this. We just need a way to detect, like, hey, this is most likely a scene change. Problem is, oh, you know what? I'm also only updating one of these expressions. I totally just realized that. I need to load up all of the expression text, and we need to have sample radius be the comp width and height. That might give us some different results. And I'm hoping by having this larger radius, we're gonna have our numbers more closely related. So like here, the max R value we reach is 102, and the minimum is like 63. So that gives us like 61%. And then when we change scenes, let's see where that puts us. 116 compared to 185. So we're looking at around, just based on the couple examples here, the scenes need to differ at least like 60%, probably 70. It's a pretty close threshold. And the problem is, these numbers are changing every frame, and they change quite a bit. I don't want to say like, hey, if this changes 60%, boom, next frame it's 60%. We need to compare one frame to the next, because this, let's see this first entire clip here, the R value ranges about 60% from its original value. It starts at 102 and goes down to almost half. So if we said to look for 60% change, this is a 60% change over the whole lifetime of the clip, but there's no 60% changes frame to frame. So I need to compare every new frame with the previous frame. If the new frame has a change of over 60%, then I think we call it a scene change. And I think that's where we go with this. So let's create a variable for our rtext. Set this equal to comp.layers.addText. We'll keep it empty for now. And we'll make one of these for our gtext and our btext. And now we're just going to put on these expressions. So for our rtext, we're going to say rtext.property source text dot expression is equal to this. Turn on a word wrap. And it's not liking this. Oh, I need to say equals. And I'm also going to go ahead and save this scene detection script. This needs to be equals. And then instead of just hard coding the name in here, we need to exit out with single quotes and then add our layer.name into there. That should be it. The rest is all based on like the comp size. So I'll go ahead and copy and paste this for our gtext and our btext. And we'll just make sure this is different here to grab the corresponding value. I know this says R and this says R, but honestly, this is fine. Now, let's go ahead and just run this. Make sure we are recreating our texts appropriately here. And we'll just say F1 run. Please select exactly one layer to analyze. Okay. So we have our text here created, no expression errors, perfect. We really don't care that these are stacked on top of each other. We're just going to be using them to read the data. And in fact, we're going to write this data to a file, move to the next frame, and compare it to the previous. So now I'm going to go ahead and say, create a function called write RGB to file. And we're going to have our R, G, and B. We're going to create a file called our RGB file. We'll put this on our desktop, and we'll just call it rgb.text. Actually, I'll put this in my documents. And now we're going to say RGB file.open to write. Then we're going to say RGB file.write. What are we going to write? We're going to write R plus new line plus G plus new line plus B. And that's going to go ahead and write those into our RGB file. We're also going to create a function that reads RGB file. Grab that same file. We'll open up that file to read. Create a variable called data is equal to our RGB file.read. And we're going to want to split it. And I think we split by that. We might have to split by new R and new line as well. We'll see. RGB file.close to make sure it doesn't leak or anything, and then return data. I'm going to go ahead and alert data and alert data.length. We may need to do some parsing of the information in the text file. Now to initialize, after we've set up these text layers, let's read their values so we can start off with a value. The first frame of our video is not going to be a scene change, so we can just store the value. So we'll go ahead and say write to RGB file. What do we want to write? We want to write R. So we want to say parse int, parse int, parse int. Because we're reading from text layers, it's going to be text. We want to convert it to an integer. I'm going to say rtext dot property source text dot value, and then just paste that for these other two, and we'll change it to gtext and forgot the btext. Btext. So we have R, G, and B. So now if I go ahead and make sure we clear this up. At the end of all this, we're actually going to want to say remove these text files. So I'll say rtext.remove, gtext.remove, btext.remove. That way it is nice and clean, at least even when we test. So we'll run this. Again, I need to select one layer to analyze. Write to RGB file is undefined. Yes it is. I'm going to say write to RGB file. And now, let's try that again. I'm going to load up my documents and see that file. I'm going to remove it and try this one more time. You can see everything got cleaned up nicely. And we have rgb.text, which contains 95, 29, and 28, some RGB values, which is super good. Now we can read those and compare them. So this is where the sort of main loop is going to come in. We're going to loop through our frames. We could maybe go every 5 frames or every frame. I honestly think we should go every frame or every 2 frames because it needs to be precise. But maybe not every frame because we may have to add a wait. So let's go ahead. I'm going to create a for loop. And also I'm going to say comp.time plus equals comp.frame duration. So after we read the first initial values, we're going to move the comp time 1 frame forward. Then I'm going to create a variable for R, G, and B. And I'm going to go ahead and comment this out real quick. We're going to do a first read RGB file function. We're going to store this into like a temporary variable, because remember, we're turning these as RGB values. So we'll say R is equal to temp 0, G is equal to temp 1, and B is equal to temp 2. Let's go ahead and run this, see if we get an alert. Select a layer. And as you can see, we get that and a length of 1. So we're not splitting these up appropriately. I think we may need to do this. Let's try that again. Still 1. Let's try just the N. There we go. That is now going to read in our RGB values just fine. Now we're going to loop through a certain period. So let's first decide how many frames we want to increment. We'll say var frame increment is equal to, let's say we want to go every 2 frames. All right. Now in our for loop, what are we going to loop through? We're going to say var I is equal to our comp dot time, I believe. This will give us the seconds of our comp time. I'm trying to think here. We need to loop through the number of frames. So we need to say var I is equal to comp.time times comp.frame duration. Again, frame duration is just the length of a frame. So if we multiply the comp time, which is seconds, times the duration of a frame, we're going to get the number of frames. Then we're going to say I is less than our comp.duration times comp.frame duration. That means, actually, so if our comp duration is 5, if our frame duration is that, that's going to give us a tiny number. So this needs to be multiplied by 1 divided by our frame duration. And we're going to floor that. Because if we take 1 divided by our frame duration, that basically gives us our frame rate. If we then take our frame rate and multiply it by our seconds, that's how many frames we need to loop through. So I'm just going to create a variable called frame rate. Set that equal to math.floor 1 divided by comp.frame duration. And we're going to say comp time times comp time times frame rate. That's going to give us the current time in frames. And then comp duration times frame rate. So if your comp duration is 5, it's going to multiply the frame rate by that. Now for our increment, we're going to say I plus equals frame increment. That'll go forward 2 frames for us. Now, what are we going to do each time we loop through this? In fact, first let's add an alert, and we'll say alert comp.time. This is going to create a lot of alerts. So what I'm going to do is reduce this to half the frame rate. And let's see how long our clip is, because this is going to go a lot. Let's make it super short, just so we can see here. This is 1 second, so it should give us quite a bit. You can see the time actually remained the same for the majority of that. So I forgot, what we also need to do is say comp.time plus equals frame increment. Now let's run that. Now you can see we're going in like 2-second increments. So that means Our frame increment is too much. Oh, that's because it's a solid 2, my bad. So the frame increment needs to be 2 times comp.frame duration. We'll run this. Now instead of 2 increments, we should get an error. I plus equals, that needs to be a solid number, doesn't it? 2 frames. This is where it's going to get tricky. Okay, so let me try this again. Our frame increment is going to be 2. That's for sure. Our frame rate, that's good too. This time, instead of starting, well, okay, we have comp time. If we're at 0 seconds, if we're at 1 second, we divide it or times it by frame rate. That's going to give us the frame number. And then we go till the length of the frames plus equals frame increment. Now our comp.time, we're trying to increment by the frames here. That's incorrect. This needs to be I times the frame increment. If we're on frame 30, it's 1 second in, and we're incrementing by 2 frames. We need to say frame increment divided by frame rate. Let's try that. Still, that's not running successfully. All right, let's set the comp time to 0 at first. That's a good starting point. We'll start it from scratch, and then we'll say frame increments 2. I is going to start out at 0 for I is less than, say, 5 seconds times 30. Alert comp.time. Let's try that. 0, 0.8, 0.1, 0.25. Now you can see it, maybe you can see it. It's going forward in time here, which is perfect. And it goes directly to the end. Let me see if I can run it from over here. It's really annoying that it loads like that. Okay, it's not letting me, but it is incrementing forward in time, which is perfect. So now that we have it incrementing, each time we increment, let's get our RGB values and compare them to previous. So let's go ahead and say this same code here. So when we start this off, we have that. We actually need to write to our RGB file first. Using the same code here. Then we go forward in time. Well, no, so we start off at frame 0. We write the details into the file, and we grab those variables here. Then we move time forward. We need to be able to compare the different times. So we start off with our values. Let's say it's white, 255, 255, 255. Then we start looping. We move the time a little bit forward so we can get a new reading. We need to change these to, we need to have like a OGR, OGB, OGG. This just means original, because I want to have the original R, the original B, or G, the original B values, and I want to compare them to the RGB here. So we move forward in time. And we need to write the values to the file. So we say move forward in time. Write new values in file. So we still have OGR, OGG, and OGB to compare to. But now that we've written to the file, we're now going to read with RG and B. So then we're going to say RG, we'll say OG Luma and Luma. OG Luma, our original Luma, is going to be equal to OGR plus OGG plus OGB. These are just the RGB values divided by 3. That'll give us our OG Luma. And then we're going to set our Luma equal to R plus G plus B divided by 3. Then we're going to say if our OG Luma divided by Luma times 100 is greater than 60, then it's greater than that threshold. So let's create a variable for that original threshold we said, which is like 60%. Say 60. We could even say 65. We'll stick with 60. If we take our original Luma and switch scenes, and we now notice that the difference in a percentage form is greater than 60, and we can also probably say or Luma divided by OG Luma times 100 is greater than 60. Then we're going to say we want to remember this time. Let's create an array called split times, and I'm going to say split times dot push I divided by frame rate. So if we're at frame 30 and we divide it by 30 frames per second, we're at second 1. We want to store our split times as that. Now, after we do this, I'm going to alert split times. I'm going to see what this gives us, if anything. Let's go ahead and run it. It's giving us the values each time here. Probably should have turned off that alert. And here are all the detected split times it came up with. Those are all not very good split times. All right, let's get rid of any unnecessary alerts we had. Got that. Remove the data. Let's change our threshold to the variable. And up here, I'm going to change threshold to a larger number so it's less sensitive. We'll say 80 or 70. Let's go ahead and try this. You can see we're still getting very, very small split times. I know we don't have a long clip right now. Let's go ahead and change that. Let's go back to the original length here and see what it comes up with. So now we have quite a bit of split times, up till 5 seconds. The problem is they're so common. These split times are very common. I'm also going to move my code over here in case if you guys have had issues seeing it this whole time. I'm so sorry if that's the case. Now we can keep this over here. So let's go ahead and see. Oh, we're not updating our. We need to update OG Luma and stuff. So after we compare these, OG Luma needs to become Luma, OGR needs to become R, OGG needs to become G, and OGB needs to become B. So we can move on to the next set of comparisons. Let's try that. It's still giving us very common cut points. Let's go ahead and alert some very complex data. OG luma divided by luma times 100 is equal to that expression itself. I'll do the same for the other way around. Luma divided by OG luma equals that. Now this might give us a lot of alerts, but will give us a better sense of what's going on. So in this case, the first difference in luma, notice, is 107. 92, 98. These are all very high numbers. Maybe he needs to be like double the threshold. 1600? It's exactly 100. Okay. Let's try something more extreme. Actually, let's set it up so that our clip is so short that we only have the transition point. That way we can just boom, boom, boom and see what the values are. So we have 2 single points here. We have the first, try this. So we get 70, 73, and 135. So that might be our number. Let's try like 130 as our luma. Or sorry, not as our luma, as our threshold. Okay, undo all this. All right, back to the 5-second clip here. Let's try it. I need to actually, we're gonna set it to reselect that layer once it's done now, because once it removes these, we need to just say layer.selected equals true. That way we don't have to keep going back and doing that. All right, we'll run this. And now we have more spread out times. Let's be more extreme. The threshold we were using was like 70, so let's double the 70. And these are what it thinks the cut points are. 0 is not a cut point though. I'm sorry to tell you that. So what I'm gonna do now, I need to get rid of that first one. So I'm going to grab split times and say unshift. I believe that's what gets rid of the first element, so we shouldn't have a 0. Maybe not. Let's go ahead and W3 it. Unshift? I swear it was unshift. Oh, is that just to add to the beginning? JavaScript. Remove first element from array. What is it called? You just do splice? Shift, not unshift. So now, we won't get that 0 because 0 is a terrible cut point, honestly. So, now there's not really any split operation, so to say, in After Effects scripting. What we're now going to have to do, now that we have these split times, we're going to have to basically, I believe, duplicate the layer that many times. And then set the beginning and end points to those values. So, create a for loop. For var I is equals 0, I is less than our split times dot length, I plus plus. For the very first case, if I is equal to 0, we're going to want to behave a little bit differently than if we have greater than 0. The reason for that is if we have I equals 0, there's no previous stuff to check. So if I is equal to 0, we're going to say layer.duplicate, and we need to have a variable for this duplicate. This is going to be the duplicate, but to create the duplicate, we're going to say layer.duplicate. So we have duplicate equals layer.duplicate, and we're going to say duplicate, let's call it duplicate layer so we don't get confused. Dot out point is going to be equal to split times I. Now for all the other cases, we're going to want to duplicate it just like that, but instead we're going to set the endpoint as well. The endpoint will be set to split times I minus 1, and the out point will be set to I. Now, I don't actually think we need to select the layer at the end now, because we need to remove it, because we're going to have all these other layers now. So we'll say layer.remove. Now let's see what this gets us. Hey, that's pretty good. It missed the first one. But look at that consistency. That's pretty good. Let's change. I didn't think it was going to analyze that fast. So let's change up the frame increment to 1. And you can see we can just easily undo that whole thing too, which is super nice. Yeah, so it's having trouble with that first scene detection, it looks like. But you can see just like right off the bat, how long has it been? 48 minutes, that's not bad. We just basically made it work. You can see it's pretty precise now that you get down to 1 frame too. A little bit of the cutting is, as you can see, because there are flashing lights in this DJ scene. So that's another thing. Maybe it needs to be steered towards checking for certain colors. But this is a great start. Like, I would be happy to upload this. I'm just trying to think of how I can make it a little bit more sensitive. I'm going to go ahead and remove that split times alert. That way everything is going to now run super fast. Let's see. Yeah, I'd say that's pretty fast. The issue now is that some things have very little luma change between them, and some things have dramatic luma change, and sometimes that's within the same scene itself. So really at this point, it would be about messing around with the threshold maybe. But I'm afraid if I take it down too low, it's going to be too sensitive. So let's try like 100. And we'll just see if we can narrow it in. So see, as soon as I go down to 100, it's detecting just the tiniest shifts. So it might have to get really specific on how detailed this is. Let's try 130. Hey, there we go. But that right there is super inaccurate, to say that. So it caught that cut, but not the other. Let's try 135. I did notice like 133 was one of the values it was messing around with, or I was getting a lot. So maybe around 135 or something. Yeah. Maybe this needs to be more dynamic too. I don't know. But this looks like the value right here is 135. We get that first clip. Next clip. And then we get all these other little clips. Let's see how it does when the lights change. You can see it's still detecting it like that. So, I mean, now it's just the creative part. How are you going to be creative to get this to better understand if there's a flashing light in the frame? Is it need to have a large tint change as well as luminance, or how is that going to work? But I think that's going to really do it for this. Let me think if there's anything else. Everything's pretty much ready for people to use. We'll just say adjust me if you're having problems. yeah, let's go ahead and push this to GitHub. And yeah, now we can split scenes pretty quickly. I might throw in let's throw in this whole video, which is much longer. It's 41 seconds in total. And I have these fades as well, so that would cause an interesting problem possibly. Let's time it. Are we ready? Gotta be quick here. I'm just gonna start the timer and then go fast. We'll see how long this 41-second video takes and how well it does, and then we'll go ahead and have an outro. I would hope that this is pretty quick, and there's been some situations in which I've used long clips like this and the sample image function, and it's had issues reloading and refreshing the values. But I think in this case it's fine. Also note, in this case, we have, what is this, 41 seconds, and the frame rate is 24. That's 984 frames, and it just did it in about 40 seconds. But also you can see it's extremely sensitive in this case. It's catching some of the cuts, but a lot of them, because of this flashing light and stuff, are getting messed up. So maybe that's a good note on the use cases of this, is that you want to be careful when using certain types of footage. Sometimes things with flashing lights like in this will, or even like glowing lights that move around, will trip up the algorithm. And also we could maybe adjust the expression. Instead of sampling the entire image, maybe we could sample a smaller portion and randomize that to make sure in different scenes we try different things. But that's going to do it for this video, guys. I hope you enjoyed. If you did, hit the thumbs up button down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel. And down in the description, you can check out the code for this I just uploaded on GitHub. Try it out for yourself, make modifications, and of course, try and find out ways to make it better for all types of footage. Make sure you follow us there on GitHub for coding updates, and in the description, follow us on Instagram for other live updates. If you're not already a member of our Discord server, you can come and join and get help with scripting, extensions, plugins, expressions, submit tutorial ideas, hang out with cool members and knowledgeable people, and much more. And if you'd like to help support us on YouTube, you can become a member, supporter, premium supporter, or VIP, which gives you cool Discord status, emojis, badges, live streams, and a whole bunch more. Link for that is in the description. Thanks again for watching, everyone. We'll see you next time.
This is